Okay, we can. If you guys have any questions, you can just ask me. No, you can put your questions in the chat. Also, can you guys hear me all right?
Yeah.
Okay, good. Do you guys really have no questions?
Maybe. Um,
So, which problems do you want me to go over?
Could you go over 8?
For 2019.
Yeah.
Okay.
eight numbers. Wait, for target or for sprint?
Sorry, what did you say?
Wait, is this target or sprint?
This is target. I mean, if you have questions about the sprint, I can take a look and uh, look at go over that too. Okay, well, I'm just gonna get started on this one first.
I don't know. After this, maybe you can go over number 29.
Okay, for which year?
29 sprint, of course.
Which year is that?
Oh, 2019.
Okay. So for this one, this problem, what you want to do is look and find a pattern. So the first number is going to be 20, it's going to be 19, and then it's going to be -1, and then we have 18, and then 17. Sorry, this is -18, I think. And then -1 again. -16, 15, -1. So like what we would do here, it's kind of like a pattern, right? So maybe we would just assume that, but that's actually not right, because maybe when we approach 0, we might have some problems. So we'll just like take a look at what's happening near 0. So one of the values is going to be -2. It's going to be 1, -1, and then would be -1, 0. 0 minus 1, -1. And then suddenly here it's going to be 1. See? Before it was all -1, but suddenly now this is 1. So let's just continue and see what happens. It's going to be 0 again. -1, 1. And then you can see that these three numbers just keep repeating. So basically now what we want to do is find like which one of these is 2019. 2019 is divisible by 3, so it's going to be the last one, so the answer should be 1. Okay, let me just go over to $29. Okay.
Wait, this thing isn't the one that was.
Okay.
Wait, are you sure this is?
Yeah, this is 20. Oh, sorry, this is chapter. Yeah. Yeah, okay. Okay. Okay, so basically so there's 12 heads, whatever. So you want to think about, probably here I would use maybe complementary counting. So you want to find a number of ways that hold on, let me just think about this problem for a little bit.
Very bad at counting stuff.
So yeah, here I would use casework actually. So basically, what can happen is there can be 4 head flips, four, uh, 4 of these, for like 3 times. There's 4 head flips, and then the tails go. There has to be 2 tails here, and the other 2 tails can go wherever. There can also be 4, 3. Oh, sorry. Yeah, actually. 3, 3, 1, I think? No, 2. Yeah. And then, so basically, you just keep doing casework until, and at the end, you add them all up. So for this case, you could have, say, 2 tails here. And then, okay, wait, so there's four tails. And then for this one, this case, you would do 5, choose 3. So like pick which heads go where these like 4 things go. And then for this case, you would do 5, choose 4, and then times 4 factorial over 2, and that's like kind of ordering these, like which one goes first, whatever. And then basically you just keep doing these, and then there's a lot of cases, but it shouldn't be too difficult. So you can like try that on your own. Any other questions? Okay then, when you come up with another question, just ask me.
Can you go over number 8 for 2020? I think you're muted.
Sorry. So for this problem, you're always going to have a few patterns. So you can either have 4 numbers in a pattern. In this case, you would have... Actually, hold on. Let me just restart. So you're always going to... So let's say you start with a 1. So when you times 2... When you have the leftmost digit as 1, your next leftmost digit is always going to be 2. So hold on, sorry. So when you have a leftmost digit that's 1, your next leftmost digit is either going to be 2 or 3. And 2, I think you know how that happens. And 3, if the digit right next to the 1 is greater than 5, then you're going to have a 3. So if you have the 2, then you're either going to have a 4 or a 5 next. Same logic there. And if you have a 3, you're either going to have a 6 or a 7. Okay. Now if you have a 4, you can either end up with a 8 or a 9. And if you have 5, 6, or 7, you always go back to the 1. And if you have 8 or 9, you also go back to the 1. So now we see that there's like that you can have either 8 or 9. So if you if the digit on the leftmost is 4. So hold on, let me think. I don't remember exactly how this works. Let me just see. Okay, yeah. So 302. Hold on. 302. Okay. So basically, for each amount of digits, you're going to have like one of these chains. And so for 302, you have this 1. And then, so basically, you're going to have three length chains before you get a four length chain. So if you have 30, so you have 301, like 301 chains, basically. And hold on. Oh, okay. So you have 301 chains. And let's say each of them has length 3. Then you would have 903 chains total. Except you know that there's 1,000 of them, or 999, because we removed that first one. So then you know there's going to be 96 groups that have 4 length. And since we know the 8 appears 52 times, then the 9 is going to appear 44 times. Does that make sense?
Yeah.
Okay. Sorry, I had to think about it, cause kind of forgot how to do it. Any other questions?
If I have no more questions, what do I do?
If you want, you can just leave the meeting. Or maybe you can try some other math concepts, and then maybe if you have questions about those, I can also help go over.
Okay, thank you. Bye.
Nathan, do you have any more questions?
I don't think so.
Okay, I guess we can just end. Or actually, I think I'm just gonna go over these a few interesting questions
Okay.
on these. So for this one, you can just read the problem really quick. Okay. So basically for this one, we want to find, so there's going to be n minus 2 cubed. This is the amount of faces that if you selected one of these faces, then all the other faces on that same cube would be unpainted.
Where's our bag or something? We need to put more laundry.
And so this is the sorry. And this is the number of faces. Sorry. Oops. This is the number of faces, like unpainted faces in total. Because this is the total amount of faces, and this is the amount of faces that are painted. And so basically you just do this over this. So you would get 6 cubed over 8 cubed minus 8 squared, and whatever that is the answer. And then, okay. I think this is also a pretty interesting problem. Can read it really quick. So basically, for this problem, you have to notice that the only numbers that have an odd number of positive factors are perfect squares, because like say you know that if you have this whatever number, the number of factors is this whatever, and so then all of for it to have an odd number of factors, then these terms all have to be odd. So like the variable inside all of the terms have to be even. So then all of them have to be perfect squares. And 2019 is greater than 44 squared, but less than 45 squared. So then there's going to be 44 positive integers. I think that's all the problems that I want to go over. Actually, this one I will also go over. So basically here, you want to just basically count how many squares, how many ways you can get to each square. So here, the first one, obviously 1. Also 1 from each. Here it's going to be 2. And here it's going to be 2 because, remember, this is considered one step in this setup. So this is also going to be 2. And then this square will be 2 plus 2 plus 1, so 5. And this square will be 5 plus 5 plus 2 plus 2, 10, 14. This is going to be 2 plus 1 plus 1, so it's going to be 4. And then you just keep doing that until you get this. Okay, I think that's all the problems that I'm going to go over, so you can just leave the meeting now. Thanks for coming.
Wait, can you play a for the win game?
Sorry, can you say that again?
Can you play a for the win game?
Could you say that again? Or just type it in chat, because I can't really hear you.
Can you play a for the win game?
Can you just type that in chat, because I can't really hear you. What is for the win game?
Okay, go on ALPS. Resources. And then there should be for the win somewhere. Yeah, this one. You can log in. And if you don't want to use your account, then you can play as a guest.
Okay, yeah, I'm just gonna do that.
Okay, now I'm gonna send you a game. And it will be password protected. 2 games, 8 problems, 30 seconds to solve each problem. And the password is just gonna be my username.
Okay.
You see? Yeah, that one. Click on it.
Okay.
Password.
What is your username?
NL00AAMC.
00
No, NL.
NL 0088.
No, 8. Just
Just
8.
8. Okay.
AMC.
And
AMC. And capitalize every letter.
okay. Okay.
Okay. Join again. So, okay. The time has passed. This thing,
Oh.
remember, you need to use harmonic.
Yeah.
Then I have to like guess for this one because I didn't really solve it. These two of 85.
Ah. Typed it wrong.
Nope. Oh, it was 36. I didn't.
Okay. Alright. That's pretty fun. Okay. I'm just going to end the
Wait.
meeting.
And also something else about this for the win thing is that you have like a status where you We try to gain shapes, and the highest shape is the icosahedron.
Okay. It's pretty cool. Okay. Thanks for coming, and I'll see you next time.
Okay, bye.